Hello everyone. Today we'll be going through AS level chemistry and the topic is electrons in atoms. Specifically the subtopic we will take subshells and atomic orbitals. This whole topic is comprising 6 videos which you can find in the playlist, and after covering through these 6 videos you will be able to cover electrons in atom, which is the main topic. So let us go through this video which is about subshells and atomic orbitals. Subshells and atomic orbitals. What is atomic orbital? Basically it's a region around the nucleus where we are having the probability of finding 95% or more than 95% probability of finding an electron. Keep in mind, we cannot 100% be sure that electron at a specific time is at that location, but it's equal to or more than 95% probability for finding that electron. So if we try to understand the concept of shells and subshells and orbitals, shell is like this one, this whole thing. This one is shell. Shell is divided into subshells. So shell is what? Shells are energy levels around the nucleus defined by principal quantum number n. So shell can be first shell 1, 2, 3. So n can be 1, 2, 3, 4. So that is basically principal quantum number. And how we are defining subshells? Subshells are basically a shell is divided into subshells like S and P are subshells. Subshells are divisions of shell S, P, D, F, each with a specific electron capacity. So S, P, and D and F, they can hold a specific number of electrons. Now, what is an orbital? Orbitals are regions within the subshells. Within the subshells, orbitals are the region orbitals are the regions within the subshells where electrons are likely to be found. Each orbital can hold maximum of 2 electrons with opposite spin, and this is basically the level 1, level 2, level 3. So we can write 1s, 2s, and 2p, then 3s, 3p, 3d, 4th level, and 5th level. And further we can go to the main energy levels, which are shells. If we go through shells, or electrons occupy principal energy levels labeled n is equal to 1, 2, 3, 4. So and this is basically nucleus, and this one will be 1, this will be 2, this will be 3. These are energy levels, or you can say shells. The higher the value of n, the higher the energy and the further from the nucleus. Each principal shell is divided into subshells, and subshells, the number of subshells in a shell equals to the shell number n. So first is having s, which first is having shell number, this one s is having 1, p is having 2, 3, d is having 5, and f is having 7 number of orbitals. And maximum number s can hold is 2, p can hold is 6, d 10, and f can hold 14 electrons. Hopefully I'm clear. So similarly n is 1 and has one subshell S, and 2 is having S and P, SPD, and 4 is having SPDF. Now, shapes and orientation of orbitals. Shapes and orientations are like this one, as you know, is a sphere shape, and this one P shape is dumbbell shape, but it can be along x-axis, y-axis, z-axis, and D is complex shape, so which is beyond the syllabus of A level. So S orbitals shape is spherical, and size increases with the principal quantum number. Every shell form N1 has one subshell. So every shell is having one subshell, which is S. So we can see from here n is 1, 2, 3, 4. So all are having s subshells over here. All are having s. So P's orbital P is shape is dumbbell shape as we discussed. Orientation, three mutually perpendicular orbitals Px, Py, and Pz first appear in n is equal to 2. P is coming first in second shell. Then D and F are d orbital, five orbitals with more complex shapes. So that is, for example, clover leaf. So first appears in third sub shell. F is seven orbitals with the very complex shape first appear in n is equal to 4 shell. Now, order of filling and key rules. So, how we will be filling this one? First is of principle, and according to this one, if we write 1s, 2s, 3s, 4s, 5s, 6s, 7s, similarly 2, 3, 4, 5, 6, 7 P, and 3, 4, 5, 6 D also, and 4, 5 we can write F, and we draw these lines. This will be the order of filling. First, we will be filling 1s, then 2s and 2p, and then 3s, then 3p, then 4s, and 3d, and then 4p and 5s, then 4d, 5p, 5s. This is the flow of filling. You can say the sequence of filling. Electrons occupy the lowest energy available orbitals first. The order is 1s, 2s, 2p, 3s, 3p, 4s, 3d, and 4p, and so on. The 4s orbital fills before 3d orbital due to its lower energy level. As we discussed, according to the rule, lower energy level will be filled first. Now the second rule, which is governing this one, which is followed by this, is Hund's rule or the bus seat rule. So according to this rule, we when filling degenerate orbitals of the same energy, for example the 3p orbitals, electrons occupy them singly first with parallel spins before pairing up. This minimizes electron repulsion. Like, this is wrong. Two electrons cannot fill in a box like up and down. This one, if there is some blank available, so it will be, this will be the right distribution for the fourth electron. Third, first will be, for example, this one. If it is having three, so first will be here, second will be here, third will be here, fourth one will come to this one. So this is basically known as the bus seat rule. Next is Pauli exclusion principle, and for this one, no two electrons in the same atom can have the same set of four quantum numbers. So you can see this is wrong, this one also wrong, this one is correct. Both cannot have upward arrow or same spin and downward arrow or same spin. So they should have opposite spin like this one. So the final thing is, practical result is, an orbital can hold only two electrons and they must have opposite spin also. So we are done with this. Hopefully you understand each and everything. Don't forget to subscribe the channel, introduce this channel to your class fellows, and recommend them also for this. Thank you very much for watching. Take care. Bye.